Welcome to this explainer. Today we're diving into a highly compact scannable summary of Chapter 5 Java Exception Handling. We're going to unpack exactly how resilient applications manage to handle unexpected, real-world errors without just, well, completely crashing. I mean, we've all been there, right? That universal frustration of a sudden program crash. Picture this. You've built an absolutely flawless application, but then a user comes along and inputs completely invalid data. Or maybe they accidentally divide a number by 0. Without a safety net in place, what happens? Your entire system just comes to a screeching halt. And then you see it. That terrifying error message. A single bad input, like an arithmetic exception for dividing by 0, literally terminates the entire program flow abruptly. It is jarring, it's messy, and it's exactly the kind of disaster we want to avoid. So here is our quick roadmap to fix this. 1. What is an exception? 2. 3 categories of crises. 3. Setting the try block. 4. Catching the culprit. And finally, 5. The finally guarantee. Let's get right into it. Starting off with Section 1. What is an exception? Basically, defining our problem. Now, the absolutely crucial first step is understanding the definition. An exception is, at its core, an undesirable runtime event or error that pops up during program execution. But here is the absolute genius of the exception handling mechanism. Its main purpose is to separate the error handling logic entirely from your main program flow. By pulling that error management out of the main sequence of your code, you ensure high readability and, most importantly, you prevent that unexpected, brutal program termination we just talked about. And you know, this isn't just some neat little trick. Exception handling is a foundational safety net. It's a core fundamental principle of Java programming, purposefully designed to ensure your code is robust and fail-safe, even when it's exposed to completely unpredictable users. Moving right along to Section 2, 3 categories of crises, or the taxonomy of errors. In Java, all of these little enemies actually stem from one master class, and that's called the throwable class. So this throwable class splits into a few manageable concepts. On one side, we have checked exceptions. You can think of these as external, real-world errors that are just outside of the program's direct control. We're talking things like a sudden network outage or maybe a missing file. The Java compiler actually forces you to handle these. Seriously, it won't even let you run the program until you do. On the flip side, we have unchecked or runtime exceptions. Now, these are internal logic blunders or program violations, like that divide by 0 issue or maybe trying to access an array index that literally doesn't exist. And then there's a third category, errors. These are severe underlying system crises that are totally outside of your control as a programmer. A classic example here is the out-of-memory error. Honestly, if this happens, you should never even try to catch it in your code. By the time this hits, it is basically a system apocalypse. Your application is entirely out of memory, the ship is going down, and it's just way too late to save the program with a clever line of code. Okay, so now for the solution. Let's look at Section 3, setting the try block, which is all about building our safety net. So Java manages runtime errors using structured blocks, and the absolute front line of this defense is the try block. This is exactly where you put that specific, risky code that you suspect might trigger a crisis or generate an error. You're basically telling Java, hey, try to execute this code, but keep your eyes wide open just in case. Let's see how this actually works mechanically. If an error just happened while you're inside that try block, Java doesn't just blindly keep reading the next line of code. Nope. Execution inside the block immediately halts. Any remaining statements in that specific block are completely ignored, and control abruptly shifts outward to go find a safety net. But where exactly does that control shift to? That brings us to Section 4, catching the culprit or the exception handlers. The safety net that catches our falling program is called the catch block, and Java uses some pretty rigid sequential logic here. You can actually have multiple sequential catch blocks following a single try block, with each one looking out for a specific type of error. Java evaluates them in order, straight from top to bottom. But here is the golden rule. Only the very first matching catch block executes. As soon as Java finds a match for that specific exception type, it runs that block's code, and the rest, all the remaining catch blocks, are completely skipped. Now, the formal rules of this mechanism highlight one other really vital scenario. What if the code in the try block is totally successful and no exception is thrown at all? Well, in that happy case, every single catch block is simply bypassed. They're ignored, and program execution just naturally resumes right after the last catch block. Easy peasy. Which brings us to our last piece of the puzzle, Section 5, the finally guarantee, or the ultimate closing block. So we've tried our code and we've caught any errors, but what if there is cleanup work that absolutely must happen no matter what went wrong? Enter the finally block. This is an optional closing block, but its power is in its absolute certainty. Whether an exception was thrown, whether it was successfully caught, or whether the error was totally avoided, the code placed inside the finally block is guaranteed to execute, for sure. It's the perfect place to do things like close database connections or shut down file readers. All right, let's test our understanding with a quick exercise. Imagine a program where a variable called lower limit is set to 50. The code enters a try block and prints entering the try block. Then it hits a condition. If the lower limit is less than 100, it throws a new exception saying lower limit violation. After that, it's supposed to print exiting the try block. This is all followed by a catch block to grab the exception, and then finally a print statement saying after the catch block. Take a second here, what you think the exact output is going to be. Okay, let's reveal the step-by-step logic. First, it successfully prints entering the try block. Next, because 50 is indeed less than 100, the exception is intentionally thrown. And because of the rules we just learned, execution inside the try block immediately halts. It never even reaches the line that says exiting the try block. Instead, it leaps directly into the catch block, printing exception lower limit violation. Finally, normal execution resumes, and it prints after the catch block. It's just a perfect controlled recovery. So, we've seen how elegant and really essential this structure is for separating error logic from main execution, right? It literally keeps our applications alive. So, I'm going to leave you with this. If you were to audit your own code today, what hidden, uncaught exceptions are waiting to fall through the cracks? And more importantly, now that you know the tools, are you ready to handle them? Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.